Next installment in the history recounted by Dasgupta is an innovation of Herman Hollerith, who was working on the US Census and had the idea that the processing of the data in the US Census, which is an extraordinarily large amount of data, right? I mean, you have, individual data about individuals that needs to be compiled and processed in some way, that there might be an automatic process by which this data could be worked with. And so the basic idea of this system is to, again, use punched cards. And so data about each individual in the census could be recorded on a single punched card that would specify things like, gender, occupation, income level, you name it. I mean, whatever data are of interest, you could represent in one or a series of punched cards, so that the holes on the cards can communicate all kinds of things, letters and numbers and whatever needs to be represented. And it's relatively easy to imagine how that can be done, how you can have a code by which a certain sequence of punched holes in a column on a card conveys in a one-to-one way a particular letter, for instance, right? And then that would allow you to spell out things on a card. And so Hollerith's idea was, if you have your data in this punched card form, then you can have machines that do things like sort the punch cards, because you can have machines take all of the cards that have a hole in a particular place and shuffle them off to one side. And then what you end up with when you feed thousands of punched cards into this system, you automatically end up with that set that you were particularly interested in a box that you can now do further processing with. And so that basic principle allowed for all kinds of time saving and labor saving machines to be generated, machines that could sort these cards in various ways, that could count certain values, add up values between different cards if needed, and all kinds of other things that you can imagine. Eventually, there were machines added that could do things like automatically copy a card, or could sort cards by, say, first letter of last name, right? Alphabetical sorting is the kind of thing that you could design a machine to be able to do. You could collate, you could put together two different stacks of cards. You could do more complex mathematical operations on values that have been extracted from cards. So, and many of these operations could be reprogrammed. So there were basically ways of kind of changing some settings on the machines to get them to separate out cards and do other kinds of processes in different ways. Another thing to notice about this system is that it includes humans at many, many points of the process. So even though it saves a tremendous amount of time, because you don't have to have an individual looking at sheets of paper, making marks for number of men in a district versus number of women, you do have to have human beings picking up cards from one box and from the processing done by one machine and putting them in a different box for processing by a different machine. So what you end up with is what might be called a human machine system. It's not exactly a computer in the normal sense that we think about it. And what you would have actually is what were sometimes called data processing centers. So you would have really like a whole warehouse of these machines and people working with cards and these machines and shuffling cards from one place to another. And you had to have a regular system for carrying out any process that you wanted carried out. I think it's kind of interesting to think about what was going on in those data processing centers that involved human movements and actions as well as the operation of machines as really very close to what today goes on in a computer chip, right? Because the computer chip is taking data and processing data of a certain kind at this very, very this now kind of small scale, but the information processing is fundamentally the same. And it's kind of wild to think that we could go from an entire warehouse to a single computer chip. And we could go from having humans so essential to the process as they were in 1890 and the early 20th century to really all of those intermediate steps being automated. And another thing that is worth mentioning about this is that Hollerith, clearly this was an extraordinarily valuable invention that he had put together. And he founded a company that later became International Business Machines, that is IBM. So you can definitely think of Hollerith as the founder of IBM in a way, which of course is very important for the subsequent history of computing. And this also points to an interesting divide in the early history of computing between what you might call scientific computing, which was focused on more complex mathematical operations, and what could be called business computing, which tended to be more focused on data processing and classification. So if you think about like sorting and classifying and counting as these are really important functions, and they're also functions that pretty readily, pretty quickly and easily go beyond beyond mathematical calculation, because sorting or classifying, that it can involve labels that really aren't about numbers. They're about other things like male and female. And so it is a slightly different wing of the history of computing that, was fed back into the other, and there's a lot of cross-pollination. But it is worth noting that there's a different set of processes that are being highlighted by Hollerith's way of thinking and his innovations than in the scientific computing side of the history, like, for instance, Babbage's analytical engine.